Well, in this video, we're going to be talking about factor theorem. So let me start by explaining what a factor is, and we'll proceed to see factor theorem. So let's consider this expression. 32 is equal with 4 times 8. I just bring this expression to inform me that there are numbers that can evenly divide 32, and those numbers are called factors of 32. I just considered 4 and 8. So 4 can evenly divide 32 and 8 can evenly divide 32. Then 32 is the multiple of 4 and 8, but the reverse is true that 4 and 8 are factors of 32. So let's proceed to factor theorem. Factor theorem said that if there is any polynomial function f of x of degree greater than or equal to 1 and any arbitrary real number c, then x minus c is the factor of f of x if and only if the value of the function at c is 0. And the reverse is true that f of c is 0 if and only if x minus c is the factor of f of x. Let's have some examples, and you will have a good understanding on factor theorem. So let's consider the first example. We do have a degree 3 polynomial here, and we're asked to use the factor theorem to determine whether x plus 1 is the factor of the given polynomial function or not, and x plus 2 is the given polynomial function or not. So let's start by the first one. X plus 1 should be expressed in the form of x minus c, which is equivalent with x minus of minus 1. Then the value of c is minus 1. So if the value of the function at minus 1 is 0, we can generalize that x plus 1 is the factor of the given polynomial function. Let's do it. F of minus 1 is just minus 1 to the third plus 2 times minus 1 squared minus 5 times minus 1 minus 6. Then this is exactly 0. So now you can generalize that x plus 1 is the factor of the given polynomial function. So let's proceed to the second one. We do have x plus 2, and x plus 2 has to be expressed in the form of x minus of minus 2, which is equivalent with x minus c, the linear polynomial x minus c. So let's find the value of the function at minus 2. Then f of minus 2 is just minus 2 to the third plus 2 times minus 2 squared minus 5 times minus 2 minus 6, which is exactly equal with 4. And we have said that just to conclude that x plus 2 is the factor of the given polynomial function, f at minus 2 should be 0. But f at minus 2 is just 4. Then now we can generalize that x plus 2 is not the factor of the given polynomial function. So let's proceed to the second example, and this is a very interesting example. We're asked to find a degree 3 polynomial, but that polynomial has just 3 factors, and the factors are x minus 1, x, and x plus 2. And the value of the function at 2 is exactly 24. So let's proceed to the solution. You can have a degree 3 polynomial by multiplying the 3 factors like x, x minus 1, and x plus 2, because we have given 3 factors of the given polynomial function. Then the product of those 3 linear polynomials gives us a degree 3 polynomial. But when we consider the polynomial function and evaluate it at the real number 2, it's not going to give us just 24. So we need to put a known coefficient here, and we're going to find the value of a. Then we will have the degree 3 polynomial. So let's find f of 2. F of 2. Then, we have given f of 2 is just 24, and let's have f of 2. F of 2 is equal to a times 2 times 2 minus 1 times 2 plus 2, which is equivalent with f of 2 is 24, and we're going to multiply a with 2, and the difference of 2 and 1 is 1, and the sum of 2 and 2 is 4. So we will have 24 is equal to 8a. Then dividing both sides by 8, we will have the value of a just 3. So the degree 3 polynomial is just f of x is equal with 3x times x minus 1 times x plus 2. So you can check that just the value of the function when x is 2 is exactly 24. And if you multiply just the 3 expressions like 3x, x minus 1, and x plus 2, it will give you a degree 3 polynomial. Thank you very much. I'll see you in the next video.